All right, let's take a look at this problem. Two cars leave an intersection at the same time. One headed west and the other headed north. The westbound car is moving at 40 miles per hour and the northbound car is moving at 50 miles per hour. 15 minutes later, what is the rate of change in the perimeter of the right triangle created using the two cars and the intersection? So now this is a right triangle problem involving something we haven't looked at, and that's rate of change in perimeter. Let's draw a picture to represent our cars. There we go. So we have westbound and north. Okay. So two cars, they start off, here's the intersection. Let's put a big I for intersection. They start off in the same place. And one's moving north and one's moving west. The westbound car is moving at a rate of 40 miles per hour. The northbound car is moving at a rate of 50 miles per hour. 15 minutes later, what is the rate of change in the perimeter of the right triangle created using the two cars in the intersection? So, some things we need to know. X, let's call X, so X is west, okay, because that's horizontal. So I'm going to, next to X, I'll just put west, just to clear things up, so west. We'll need to know Y. And X and Y are how far the car has traveled. The 50 miles per hour and the 40 miles per hour aren't the distance, they're just the rate that they're moving at. And then we'll need to know dx dt, dy dt, the distance s there between the cars, and ds dt. Because now the perimeter of our triangle here, we just add up the sides, right? X plus y plus s. So to find the perimeter of the triangle, you just add up the sides there. So we're going to need to, and all of them are changing. The distance between those cars is changing as they're moving farther and farther away from one another. So we're going to have to find all of these values here to be able to find the rate of change in our perimeter. Okay. And it might be that we have to use two equations. But this is our ultimate goal, it's the perimeter one over there. So I'm going to put that over there. All right, let's see what we know. We clearly know dx dt is 40. And dy dt is 50. X and y we can figure out by looking at the speed of the cars and how long they're traveling, right? So our distance, our horizontal distance, I'll just put d for distance, and I'll put a little x, because it's the horizontal distance there, is just the, the rate times the time, right? So it's 15 minutes times the rate the car is moving at, which is 40. So 40 times, now we can't use 15 minutes, right, because it's 40 miles per hour. That 40 is per hour. 15 minutes, I'll put it right here, 15 minutes is 1/4 of an hour, right? So they're going to, in 15 minutes, they're going to travel, if they do 40 miles per hour, they're going to do 40 times 1/4 in 15 minutes, which would be 10 miles. And likewise, the distance that the northbound car is moving, it goes 50 miles per hour. It's traveling for 1/4 of an hour, so that's going to be 12.5 miles. Okay. So there we've got two of our measurements. It is a right triangle, so we can define S there. S is just going to be a different colored pen so you can see. If we use Pythagorean theorem, S squared is just equal to x squared plus y squared. So we know that this car has moved 10 miles, so 10 squared, and this car has moved 12.5 miles. So S squared is equal to 100 plus, and 12.5 squared, if I can grab a calculator, is 156.25. So S squared is equal to 256.25, and we'll take the square root, and that's not very pretty. I'm just going to get a decimal approximation. So that would be, oops, sorry, just put the wrong number in the calculator there, 256.25, and that would be 16.0078, so forth. I'll take that to the third decimal place. I don't like to round too much, but working with the square root of 256.25 on a real world problem kind of seems a little strange. So 16.008 is S there. Okay, so now we have that. Now, if we're looking at our perimeter formula, we're going to need x squared. We're going to need to know what dx dt, dy dt, and ds dt is to be able to find the rate of change in the perimeter. So we have one unknown variable here, which is our ds dt. So we're going to have to use this formula here to be able to find our ds dt. All right, so let's take the derivative of that. So sometimes you have to use a related equation to get the rate, get a missing rate, and then you can solve, for what you were looking for. In this case, we're looking for a dp dt, the rate of change in the perimeter. Okay. So we have, we're going to take the derivative of s squared plus x squared plus y squared. We're going to use implicit differentiation. So we have 2s ds dt plus 2x dx dt. Oops, sorry. One of my pluses was supposed to be an equals. To x dx dt plus 2y dy dt. All right, so now we can divide everybody by 2. We've got s ds dt equals x dx dt plus y dy dt, and then ds dt, put that down a little bit, is just going to be x dx dt plus y dy dt, all divided by s. Move that down a bit more. All right, so ds dt, x was 10, so 10 times 40 plus 12.5 times 50, all divided by 16.008. And what I probably should do, so I don't have any rounding error, let's divide by the exact number. Let's divide by the square root of 156, or what is it, 256.25. Let's just work with that one, okay? Probably should have left it like that to begin with. Because all I'm going to do is just find a number. I'm just going to use it to calculate out our ds dt anyway, so it's fine like that. All right, so somewhere I have a calculator. And so we get 40 plus 12.5 times 50. Oops, I put 40 instead of 400 there. 400, because 40 times 10 would be 400. 400 plus 12.5 times 50, and then divided by the square root of 256.25 is 64.03. So ds dt is 64.03. The digits after that are 1, 2. So I'll put a 1 in there. All right, so now we have ds dt. Now we can find the rate and change of the perimeter because we have everything we need. 031. We've got our x, y, dx dt, dy dt, s, and ds dt. All right, so we take the derivative of perimeter. Derivative of p would just be dp dt. The derivative of x is just dx dt. Derivative of y is dy dt. And the derivative of s, ds dt, right? These are just implicit differentiation with respect to time. They're all single variables, so that's all we're going to have left. So now all I have to do is basically just add, plug it in and add. So this was the easiest part of all. The hardest part is just finding all your values. All right, so dx dt is 40. dy dt is 50. And ds dt is 64.031. And so our rate of change is just going to be, rate of change in the perimeter of that right triangle is going to be 90 plus 64 is going to be 154.031 miles per hour. Okay? Make sure you use the same units of measurement. Actually, I left off on my ds dt. This was in miles per hour. Okay? All of our rates are in miles per hour. So that's the rate that the perimeter of our triangle is changing every hour. Okay? So hopefully this is just another problem involving a right triangle. You'll definitely see some perimeter problems, and really it just uses all the things that you've already been working with. Okay? Bye for now.